All right, welcome to the first segment of balancing and predicting reactions. The first step we want to take is to assign oxidation numbers. +1, -2. Hydrogen's always +1 unless it's with a metal. Pure elements by themselves are 0. The oxygen's -2. There's 2 of them, so I have to counterbalance a -4, which makes my sulfur +4. And in water, we have -2. +1. Now let's take a look at our changes. Sulfur went from -2 to +4. So that makes it less negative, so it lost electrons. And in fact, it lost 6 electrons. Now the oxygen, and especially all of the diatomics, get a little tricky. Notice it went to 2 different places. So we're only going to be able to put in 3 of our coefficients. But in both places, the oxygen gained electrons and at least 2. So instead of saying 0 to -2 is 2, since I have a diatomic, I'm going to call that 4 electrons. I'm going to treat the diatomic as one substance. Now I can't lose or gain differing numbers of electrons, so I need to multiply by the lowest whole number ratio. And they're both evenly divisible into 12, so I'm going to multiply the sulfur 1 by 2 and the oxygen 1 by 3. Means I need a 2 in front of the H2S, a 2 in front of the SO2, a 3 in front of the O2. Now typically you will be able to put in 3 of your 4 coefficients. In this case now we can just finish it off using our normal balancing. And I have 4 hydrogens on this side, so I need 4 hydrogens on that side. I'm going to double check on my right hand side and left hand side that I have the same oxygens. I have 2 plus 4 over here, 6 oxygens and 6 oxygens there. So we are balanced. Now just a few more words before we leave this one. I would say the sulfur 2 negative species was oxidized. Be really careful. Some people would have said H2S, but I wanted to be specific there. Was oxidized. And that makes it the reducing agent. Gets our terminology down there. And our O2 was reduced, making it our oxidizing agent. Now let's do the same thing with our next problem. Step 1, you've got to get those oxidation numbers. The one in the middle will typically have to be done using a little bit of algebra. The oxygen's -2, the hydrogen's +1. So I've got -8 plus 1 is a -7 that I have to counterbalance, which means the manganese is +7. -1 plus 1, -1 plus 2, 0, +1, -2. If you're having trouble doing oxidation numbers, please come and see me and I can give you a little mini tutorial on that to firm that up. Now our manganese went from manganese +7 to +2. So that's more negative, so it gained 5 electrons. And our chloride, now this is going to be a little tricky because look what happened. Some of our chlorides stayed the same, but some went to 0. So the amount that went to 0 was less negative, and at least 2 of them were oxidized. So I'm going to call that a loss of 2 electrons. Now we need our lowest whole number ratio for these, and the lowest whole number ratio of 5 and 2 is 10. So I'm going to multiply the second one by 5 and our first one by 2. But here's where our difficulty is. We will not get to put in all 4 coefficients. I can for my manganese. I can put in a 2 and a 2. But not all of this chloride changed. So I can't fill in this blank until I can use normal balancing at the end. But I can put a 5 here because I know that that balanced my electrons. Remember, we have to balance electrons, we have to balance charge, and we have to balance mass. Now I can get this chloride by normal balancing techniques. If I looked at my left-hand side, I have 10 plus, 4 plus 10, I have 14 on this side, so I need 14 on the left-hand side. And to balance my hydrogens, I have 2 hydrogens plus 14, I have 16 hydrogens on the left-hand side, so I need an 8 to get to my waters. Now, the next step will be in the next mimeo. It's going to be a little trickier because it's common to give you just a skeleton equation and ask you to provide the H pluses or OH minus, whether it's acidic or whether it's basic. So join me in the next mimeo clip and I will show you how to balance acidic and basic